Welcome to Global Tales Expo, your trusted source for defense insights, strategic analysis, and the evolving strength of the Philippine maritime forces. Across the vast blue expanse of the West Philippine Sea, history is once again being written. The sun rises each morning over waters that have witnessed centuries of trade, conquest, diplomacy, and struggle. These are not just any waters. They are among the most strategically significant maritime corridors on Earth, where nearly one-third of global shipping passes through, where energy resources worth trillions lie beneath the seabed, where ancient fishing grounds sustain millions of lives, and where the future balance of power in the Indo-Pacific will be decided. For decades, the Philippine Navy sailed with courage, but often without the tools necessary to fully defend the nation's maritime lifelines. Aging hulls creaked through waves that once seemed friendly, but now felt uncertain. Limited sensors struggled to see beyond the horizon. Outdated weapons, if they worked at all, offered little more than symbolic resistance against modern threats. This was the reality Filipino sailors faced every time they put to sea. They relied more on skill and determination than on modern technology. They patrolled with pride, but also with the quiet knowledge that if a real crisis came, their options would be limited. Officers trained their crews not just in tactics, but in improvisation. Engineers kept decades-old systems running through ingenuity and sheer force of will. Entire generations of naval personnel learned to do more with less, to stretch resources, to make aging equipment last just one more year, one more patrol, one more mission. It was a testament to Filipino resilience, but it was also unsustainable. The gap between the Philippine Navy and regional peers was not just widening, it was becoming dangerous. But that era is ending. Today, the Philippine Navy is stepping into a new chapter, one defined by modern combat systems, credible deterrence, and strategic relevance in one of the world's most contested maritime regions. This transformation did not happen overnight. It required political will, strategic vision, sustained funding, international partnerships, and most importantly, a fundamental recognition that the old way of doing things could no longer protect Philippine sovereignty in the 21st century. And standing at the center of this transformation is a new warship, a new shield, and a powerful message: the BRP Miguel Malvar, and the integration of the GÖKDENİZ Close-In Weapon System, also known as the CIWS. This is not just about a gun mounted on a deck. This is not merely another piece of equipment to be cataloged in naval inventories. This is about survival in modern naval warfare, where split-second decisions determine whether ships return home or disappear beneath the waves. This is about sovereignty, about the ability of a nation to patrol its own waters without fear or hesitation. This is about the Philippines declaring quietly but firmly that it will no longer sail undefended into an increasingly dangerous maritime environment. To understand why the BRP Miguel Malvar matters, we must first understand the long road that brought the Philippine Navy here. This journey spans decades of difficult choices, delayed programs, competing priorities, and hard lessons learned from watching other nations modernize while the Philippines struggled to keep pace. For much of the post-Cold War era, the armed forces of the Philippines were structured primarily for internal security operations. Counterinsurgency dominated strategic thinking. Disaster response absorbed resources and attention. Territorial patrols against smugglers and illegal fishermen defined daily operations. These were important missions certainly, but they oriented the military inward, toward threats within Philippine territory, rather than challenges approaching from beyond the horizon. External defense, especially maritime defense, was often postponed. There were always more immediate concerns: insurgencies in the countryside, natural disasters requiring rapid response, political instability demanding attention. The Navy received what resources remained after these priorities were addressed, which was rarely enough. As neighboring navies modernized rapidly, acquiring advanced frigates, corvettes, submarines, and sophisticated weapons systems, the Philippines fell behind. The technological gap grew from years to decades. By the early 1990s, the warning signs were impossible to ignore. Regional dynamics were shifting in ways that directly threatened Philippine interests. The loss of U.S. bases at Subic Bay and Clark Air Base in 1991-1992 removed a major security buffer that the Philippines had relied upon for generations. While the decision to close these bases was driven by legitimate sovereignty concerns and domestic political pressures, it also left a strategic vacuum. The massive American military presence that had served as a deterrent simply vanished, and the Philippine military was not yet ready to fill that void. Maritime disputes in the South China Sea intensified throughout the 1990s and into the 2000s. What had once been abstract territorial disagreements became concrete confrontations. Foreign vessels increasingly operated near Philippine waters with growing confidence, testing boundaries, asserting claims, and demonstrating capabilities that far exceeded anything the Philippine Navy could match. Shoals and reefs that had been undisputed for generations suddenly became flashpoints. Filipino fishermen found themselves being harassed, arrested, or turned away from traditional fishing grounds by foreign Coast Guard and naval vessels. The sea, once a natural shield that protected the archipelago, was becoming a vulnerability. It was clear that something fundamental had to change. In 1995, the Philippines took a critical first step. The AFP Modernization Act was enacted with the ambitious goal of rebuilding the military into a force capable of defending national sovereignty in all domains, land, air, and sea. It envisioned modern ships cutting through waves with powerful sensors scanning the horizon. It imagined aircraft patrolling the skies with advanced radar and weapons. It planned for a military that could stand shoulder to shoulder with regional peers and allies. On paper, it looked transformative. But reality intervened, as it so often does. The Asian financial crisis struck in 1997, devastating economies across the region and forcing governments to make painful budget cuts. Political transitions brought new administrations with different priorities. Corruption and mismanagement siphoned away resources. Competing national priorities, education, infrastructure, healthcare, all made legitimate claims on limited government funds. Modernization moved in phases, often delayed, often underfunded, often falling short of original ambitions. Programs were announced, then postponed. Contracts were signed, then renegotiated. Ships were promised, then delayed by years. Filipino sailors watched as their neighbors commissioned one new vessel after another while they continued patrolling in ships that were older than they were. It was frustrating. It was demoralizing. But they persisted, because that is what Filipino sailors do. It was not until 2012, when the law was revised and refocused under the revised AFP modernization program, that modernization gained real momentum. This time, the emphasis was clear and unambiguous: territorial defense, maritime domain awareness, credible external deterrence. The threats were named openly. The requirements were specified precisely. The funding, while still constrained, was more reliable and sustained. And at the heart of that strategy stood the Philippine Navy, recognized finally as the primary guardian of an archipelagic nation's survival. The Philippines is an archipelagic nation of more than 7,600 islands, stretching across hundreds of thousands of square kilometers of ocean. This geographical reality is both blessing and burden. The islands are beautiful, diverse, rich in resources and culture, but they are also separated by water, connected only by sea lanes that must remain open and secure. Its economy depends on sea lanes. Over 90% of Philippine trade moves by sea. Every product imported, every export shipped to foreign markets, every container of goods, all of it travels through maritime routes that must remain safe and accessible. If these sea lanes were threatened or closed, the Philippine economy would face immediate crisis. Prices would spike, supply chains would collapse, entire industries dependent on international trade would grind to a halt. Its food security depends on fishing grounds. Millions of Filipinos derive their livelihood directly from the sea. Fish provides the primary protein source for much of the population. The fishing industry employs hundreds of thousands of people and supports countless coastal communities. When Filipino fishermen are prevented from accessing traditional fishing grounds by foreign vessels, it is not just a matter of territorial pride. It is a direct threat to food security and livelihoods. Its energy future depends on offshore resources. The waters surrounding the Philippines contain significant deposits of oil and natural gas, resources that could provide energy security and economic development for generations. The Malampaya gas field alone supplies a substantial portion of Luzon's power generation. Future exploration and development of these resources require a secure maritime environment where Philippine companies can operate without intimidation or interference. Control of the sea is not optional, it is existential. For an archipelagic nation, the sea is not a barrier, it is the highway, the pantry, the energy source, and the first line of defense all at once. Yet modern naval warfare has changed dramatically from the era when battleships ruled the waves and victory went to whoever had the biggest guns and thickest armor. Today's threats do not always come from large enemy fleets sailing in formation toward a dramatic showdown. They come from supersonic anti-ship missiles launched from beyond the horizon, traveling faster than the speed of sound. They come from low-flying cruise missiles that hug the sea surface, nearly invisible to radar until the last moment. They come from armed drones, cheap to produce and deploy, capable of overwhelming defenses through sheer numbers. They come from swarming aerial threats that approach from multiple directions simultaneously. They come from precision strikes launched from hundreds of kilometers away, giving defenders mere minutes to react. In this environment, a ship without layered defenses is a ship at risk. And this is where the close-in weapon system becomes critical, representing the final shield, the last line of defense when everything else has failed or been overwhelmed. In naval combat, defense is layered, like the concentric walls of a medieval fortress, each layer designed to catch threats that penetrate the previous one. Long-range missiles engage threats far away, destroying aircraft and missiles while they are still dozens or even hundreds of kilometers distant. These are the outer walls, the first line of defense. Medium-range systems handle leakers, the threats that somehow make it through the outer defense layer. These are the secondary walls, providing redundancy and additional protection. But if everything else fails, if the outer defenses are overwhelmed or malfunction, if missiles penetrate through every layer of protection, there is only one final shield left. The CIWS, a system designed to react in seconds, to track targets automatically without human intervention, to fire without hesitation, to destroy incoming threats just moments before impact, when there is no time left for anything else. For decades, many Philippine Navy ships lacked this final layer. They had courage, they had skilled crews, they had determination. But they did not have the automated, rapid-fire, last-ditch defensive capability that modern naval warfare demands. If a sophisticated anti-ship missile ever targeted these vessels, the outcome would likely have been tragic. The sailors aboard knew this. They understood the risks they faced every time they sailed into contested waters. They went anyway, because duty demanded it. The BRP Miguel Malvar changes that reality fundamentally and permanently. Developed by Aselsan, Turkey's leading defense electronics company and one of the largest defense contractors in Europe, the GÖKDENİZ CIWS represents a new generation of close-in naval defense. The company has decades of experience in military electronics, radar systems, and automated weapons, experience now distilled into this sophisticated system. Its name, GÖKDENİZ, translates to Sky Sea, a fitting description for a system designed to dominate the space between air and water, the dangerous zone where missiles fly low and fast, where seconds determine survival, where automation must triumph over human limitations. This is not a legacy Cold War gun bolted onto a ship as an afterthought. This is not a decades-old design barely upgraded for modern threats. This is a modern, purpose-built, digitally controlled defensive weapon system built specifically for 21st century threats. Every component, every sensor, every algorithm has been designed with current and future threats in mind. At its core, the GÖKDENİZ system features dual 35mm automatic cannons, each capable of unleashing devastating firepower. The choice of 35mm is deliberate, large enough to carry significant destructive energy and sophisticated ammunition, yet fast-firing enough to engage multiple targets in rapid succession. Together, these cannons achieve a combined firing rate of up to 1,100 rounds per minute. That is more than 18 rounds per second, a virtually continuous stream of metal and explosive force directed at incoming threats. The effective engagement range extends to approximately 4 kilometers. This might seem short compared to missiles that can strike from hundreds of kilometers away, but it is precisely calibrated for the CIWS role. These are the final 4 kilometers, the last precious seconds before impact. In that space, the GÖKDENİZ creates a defensive umbrella of fire that few threats can penetrate. The system offers fully automated operation with manual override capability. In automatic mode, it detects, tracks, and engages threats without human input, operating at computer speeds that far exceed human reaction time. But operators retain the ability to override, to make judgment calls in ambiguous situations, to maintain human control over lethal force even while benefiting from automation speed. This balance is crucial: automation for speed, human judgment for wisdom. But what truly sets the GÖKDENİZ apart is not just firepower. It is intelligence. Modern naval defense is as much about information processing as it is about bullets and explosives. The system integrates multiple sensor types to build a comprehensive picture of the threat environment. Electro-optical sensors provide visual tracking, allowing operators to see exactly what the system is engaging. Thermal imaging ensures tracking continues even through smoke, darkness, or weather that would blind purely optical systems. Fire control radar provides precise range, speed, and trajectory data, predicting exactly where a target will be milliseconds into the future. Advanced tracking algorithms process this sensor data in real time, discriminating between threats and non-threats, prioritizing targets and calculating optimal engagement solutions. This allows the GÖKDENİZ to detect, identify, track, and engage a wide variety of threats. Sea-skimming anti-ship missiles that fly just meters above the waves, low-altitude aircraft attempting to avoid radar detection, unmanned aerial systems that might be small and hard to see, maneuvering and evasive targets that try to jink and dodge their way through defenses. All within seconds, from first detection to final engagement. Human reaction time alone is not enough in modern missile combat. By the time a human observer sees a threat, identifies it as hostile, decides to engage, and triggers weapons, a supersonic missile has already covered kilometers. It might already be too late. Automation saves ships. Automation saves lives. One of the system's most lethal advantages is its use of programmable airburst munitions, a technology that represents a revolution in naval point defense. Traditional CIWS systems rely on direct hits, where projectiles must physically impact the incoming missile to destroy it. This requires extraordinary precision and a bit of luck, especially against small, fast maneuvering targets. Programmable airburst munitions change the equation entirely. Instead of relying on direct hits, these rounds detonate at precisely calculated points near the target, releasing a cloud of high-velocity fragments that expand outward like a lethal sphere. The fragments do not need to hit the target directly. They only need to pass through the same space, shredding control surfaces, puncturing fuel tanks, destroying guidance systems, or detonating warheads. This dramatically increases kill probability against several threat types. Fast, agile missiles that might dodge direct fire rounds cannot dodge an expanding cloud of fragments. Drones with small radar signatures that are hard to hit directly become much easier to destroy when surrounded by shrapnel. Saturation attacks, where multiple threats approach simultaneously, can be engaged more efficiently because each burst can potentially damage multiple targets. It turns the air itself into a defensive barrier. An incoming missile does not just have to evade bullets. It must fly through a gauntlet of precisely timed explosions, each creating a lethal zone that is nearly impossible to avoid. The programming happens automatically, in real time, as each round is loaded into the cannon. The fire control system calculates the optimal burst point based on target range, speed, and trajectory, then programs the fuse accordingly. All of this happens faster than human thought, ensuring every round is optimized for maximum effectiveness. The decision to integrate the GÖKDENİZ CIWS was not accidental or hasty. It followed extensive evaluation of available systems from multiple countries, a process that considered numerous factors beyond pure performance specifications. Cost-effectiveness was paramount. The Philippines needed a system that delivered real capability without bankrupting the defense budget. Some Western CIWS options offered excellent performance, but at price points that would have consumed resources needed for other modernization priorities. The GÖKDENİZ offered competitive pricing that made it accessible. Performance against modern threats was thoroughly evaluated. The system was tested against simulated anti-ship missiles, drones, and other threats representative of what the Philippine Navy might actually face in combat. It passed these evaluations convincingly, demonstrating that it could perform its mission under realistic conditions. Compatibility with ship sensors and combat systems was critical. A CIWS does not operate in isolation. It must integrate seamlessly with radars, fire control systems, and the overall combat management architecture. The GÖKDENİZ was designed with modern digital interfaces that facilitate integration with diverse ship systems. Ease of maintenance and training affected long-term sustainability. A sophisticated system does no good if it cannot be maintained, or if crews cannot be trained to operate it effectively. Turkish systems came with comprehensive training programs and maintenance support, ensuring Filipino sailors could master and sustain the system. Political and strategic partnerships played a role. Defense procurement is never purely technical. It involves relationships between nations, technology transfer agreements, and strategic considerations. Turkey's willingness to engage seriously with Philippine defense needs, to offer meaningful partnerships rather than just arms sales, made a difference. Aselsan's GÖKDENİZ system offered a compelling balance of capability and affordability without sacrificing performance. It represented proven technology, already in service with the Turkish Navy, at a price point that made fleet-wide adoption feasible rather than aspirational. Just as importantly, it came with something else, a new strategic relationship that extends beyond a single weapon system. The acquisition of the GÖKDENİZ CIWS marks a deepening of defense ties between Manila and Ankara. Turkey has emerged as a major global defense exporter over the past 2 decades, transforming from primarily a customer of Western defense technology into a significant producer and exporter in its own right. The country now offers proven combat systems tested in actual conflicts, flexible technology transfer arrangements that allow partner nations to develop indigenous capabilities, competitive pricing that undercuts traditional Western suppliers, and willingness to engage in long-term partnerships rather than one-off sales. For the Philippines, this relationship goes beyond a single weapon system. It includes comprehensive training for Filipino sailors and technicians, ensuring they can operate, maintain, and troubleshoot the system independently. It includes maintenance and lifecycle support, with spare parts, technical assistance, and system upgrades. It opens potential future collaboration in naval electronics, fire control systems, and other technologies where Turkey has demonstrated expertise. Perhaps most importantly, it involves knowledge transfer that supports long-term self-reliance, moving the Philippines toward indigenous defense capabilities rather than perpetual dependence on foreign suppliers. This is modernization with sustainability in mind, building not just capability but capacity. The BRP Miguel Malvar is not just a platform for a CIWS. It is a symbol of transformation, representing the Philippine Navy's transition from a coast guard with naval pretensions to a genuine fighting force capable of modern naval warfare. The ship itself embodies lessons learned from decades of inadequate capability and regional observation of what works in contested waters. A guided missile corvette designed to operate in contested waters, the vessel represents a class of warship optimized for the mission profile the Philippine Navy actually needs. Not overwhelming firepower for open ocean battles against major powers, but credible capability to patrol territorial waters, deter aggression, operate alongside allies, and survive if combat occurs. The ship incorporates reduced radar cross-section shaping, with angles and surfaces designed to deflect radar energy away from enemy sensors rather than reflecting it back. Signature management features control infrared, acoustic, and electromagnetic emissions that might give away the ship's position. Compartmentalization for damage control ensures that hits or flooding in one section do not doom the entire vessel. Modern electronic warfare systems detect, identify, and potentially jam enemy radars and communications. Survivability is no longer an afterthought added after the ship is designed. It is built into the design from the beginning, informing decisions about layout, materials, systems, and capabilities. Every choice reflects a simple question: will this help the ship survive in combat? The vessel is equipped with modern 3D surveillance radar that tracks multiple air and surface contacts simultaneously while determining their altitude and range. Navigation and fire control radars provide precise tracking data for weapons engagement. Sonar systems enable anti-submarine warfare, detecting submerged threats that might otherwise approach undetected. Integrated combat management systems tie all these sensors together, fusing their data into a coherent operational picture that gives commanders real-time awareness of everything happening around the ship.